All right, so I already had some questions about the application problems that were assigned for today. So I kind of wanted to do a quick video and just review, go and look at some of the Delta Math assignments to kind of make sure we're all on the same page. So there's three main categories when you're talking about the application problem. So you have your basic, growth, and decay. So with the basic, growth, and decay, the difference is going to be your plus or your minus. So your plus is going to be for growth and your decay is going to be your minus. So your A is your initial value, okay? Your R is your rate, and your T is your time. So then it may say that you're doing growth that is compounded quarterly. Well, compounded quarterly means 4 times a year. So you basically have the same formula for growth, except for you're going to put 4 here and 4 here because you're compounding it 4 times. And then we have continuous. So continuous has got your natural base E. So you have your initial value, your natural base E, your rate, and your time. So again, I'm going to go through a few of these examples from the Delta Math to make sure we're kind of all, like I said, on the same page. All right, so looking at the first, so when I'm looking at the first example up here, determine whether it's growth or decay and find the percentage. So the percentage is going to come from how many decimals it is above 1 or how many decimals it is below 1. So when I'm looking at this problem, I'm going to screenshot this right quick. So when I'm looking at this problem, I'm looking at my base. Now my base is 1.19. So I have 1.19. So this is going to be growth because this is greater than 1. Now, what is the percentage? Well, to find the percentage, in your original formula, you did 1 plus R. So if I'm going to find how far it is above 1, I'm going to subtract 1. And that's going to give me 0.19%. Okay? If you want to plug that into Desmos, you can. And then once I plug that into Desmos, I could do 1.19 minus 1. And I get 0.19. Now I need to turn this into a percentage. So in the video, when you actually put it into the equation or in the formula, you divided it by 100 to turn it into a decimal. So we want to take our decimal and turn our decimal into a percent. So we're going to multiply it by 100. So my answer here is going to be 19%. So this is going to be 19%. So it's going to be growing at 19%. All right, so let's see if the next one will give me a decay. So I'm actually going to keep going until I find a decay problem. All right, so we have decay here. I know this is decay because my base is less than 1. So my base here is less than 1. So if it's less than 1, that's going to be decay. And I still need to find how much difference it is below 0. So remember, when we do decay, it's 1 minus my rate, raised to t. So I'm going to do 1 minus 0.23. Now, if you make the mistake and you do 0.23 minus 1, that's okay. It'll just be negative. Just drop the negative, okay? So I'm going to go to Desmos, and in Desmos, again, I can do 1 minus 0.23, and that's going to give me 0.77, or I can do 0.23 minus 1. Like I said, it's going to give you a negative. That negative, you just drop it. So it's 0.77 decimals away from 1. So 0.77 as a percentage, multiplied by 100, is going to be 77%. So this was decay, and my decay was 77% because it was 77 decimal places below 1. Okay, so hopefully that helps with the growth or decay. So when you're looking at the growth or decay, you look at the base and you figure out how much it is above 1 for growth, and you figure out how much it's below 1 for decay. All right, so my next section, so compounding. So this one, it says Samantha invested $67,000 in an account paying an interest rate of 3.9% compounded continuously. Assuming no deposits or withdrawals to the nearest dollar, what would they have after 7 years? So again, I'm going to screenshot this and I have compounded continuously. So I told you at the beginning of the video, continuous means I have to use a certain formula. So we're going to use the continuous formula, which is y equals a times e raised to RT. So a is my initial value, and my initial value in this problem was the $67,000 that was invested. All right, my R is my rate. My rate in this problem was 3.9%, but we can't plug in 3.9%. We have to take that percentage and divide it by 100, which is going to give me 0.039. And then my time is 7 years. So my time is my years, and they gave me 7. So I'm going to plug all that in. So I have y equals, my initial value was 67,000. And then I have e, because e is my natural base, and I'm going to raise that to 0.039 times my 7 years. And I can plug this right into Desmos. This is not something that I need to calculate by hand. So I have 67,000, and I'm going to type in E. And we raised that to, let me go back in, it was 0.039 times, and I need to put this in parentheses, I forgot about that, in order to make sure it's all in the exponent, and 7 years. And we get $88,031.03. So it said round it to the nearest dollar. So if we round it to the nearest dollar, I have 0.3. That 0.3 is going to round down, so it should be 88,031. So all you would come here, $88,031, and that's all you need to put in. This one's quarterly. All right, so let's look at quarterly. Now, so it says Jaden invested $65,000 at 2.1% in compounded quarterly. So we have our initial value, A. We have our interest rate, but we can't do 2.1%. We're going to divide it by 100. So my rate is going to be 0.021. And compounded quarterly. So I now have a compound of 4 times a year. I also have a time, which is 7 years. So my formula here is y equals a times 1 plus r divided by n raised to nt, because it's compounded. All right, and all I should have to do is plug in what I know. So my initial value is going to be 65,000. 1 plus my rate, which was 0.021, over the compound. So quarterly is 4 times a year. And we're going to raise that to 4 times 7 years. Okay? So again, I can go put this directly into Desmos. So it was 65,000. 1 plus, I'm going to go ahead and hit the division sign and go ahead and create that fraction. So 0.021 over 4. Raised to, now make sure you put this in parentheses as well. We have 4 times 7 years. And again, I think that one said to round it to the nearest $10. All right, so if I round this to the nearest $10, 75,264. So the nearest $10 is going to be my 6. So $10 is going to be the 6, so that's going to round down to 60. So 75,260. All right. So again, to the nearest dollar, if we didn't understand that just a second ago, and they explained by writing. So it didn't say to the nearest tenth. So the nearest tenth would be the first decimal place after, but that's not what they said. They said to the nearest $10. So $10 is that second decimal whole number. So when I'm looking at this 6, this 4 is going to cause that to stay a 6. So they rounded this. So please be careful with your rounding. I'm not sure how, I think you have to be pretty accurate with these, so make sure your rounding matches. All right, so now we have solve for time. So solving for time here, it says that Aubrey invested $61,000 in an account paying an interest of 1.9 compounded continuously. So compounded continuously, we're going to be using y equals p raised to rt. And sorry, I know I use p right here. I'm used to my Math 1 kids, but we can use a. It really doesn't matter which one you use as long as you know that's the initial value. So that's my a. I have my rate, which my 1.9 divided by 100 is going to turn into 0.019, compounded continuously. Now, here's the thing. They want to know the time. We are going to solve for t. You can do this by hand, or I'm going to kind of show you how to do this in Desmos. And they want to know how long it's going to take to reach this value. So 73,600 is my final value that I got. My initial value was 61,000. E raised to 0.019, and I'm going to put x. I'm not going to put t, I'm going to put x. And the reason I'm going to do that is because in order to solve this in Desmos, we need to split this up into two equations, and Desmos needs an x value, okay? So I'm going to go put this in Desmos. All right, so I'm going to do y equals 73,600 and y equals 67,000 e raised to, oh, it was 61,000. Sorry about that. So 61,000, and our interest rate was 0.019, and instead of t, I'm going to put x. Now, in the video for the play posit, you can't see your intersections. You have to be able to see those. So I always look at this y value that I have the largest. So it's 73,600. So if you hit the little gear over here in the top corner, if you can see me tapping that, and then go to your y-axis. And under the y-axis, you have basically like an inequality. You have your lowest value here, and you have your highest value here. We'll change your highest value. I'm going to change it to 75,000 and give myself a little wiggle room. And when I do that, I can see my graphs, and then I can just kind of scroll. So I find that intersection, and my x value here is 9.88. So 9.88 is how long it's going to take that, but it said round it to the nearest tenth of a year. So the nearest tenth of a year, so tenth is right here, so we're going to round it to 0.99. So it's going to take 9.9 years in order to get to 73,600. Now, like I said, they are going to show you how to work this out by hand, and I have no problem with you doing that. I'm just trying to give you a way to look at it and understand it without having to go through the whole process. Okay? Same thing would happen if it was compounded quarterly or compounded whatever. You use your formula, you plug in the values that you know. So if I solve for the rate, same process here. When I solve for the rate, I'm going to start with, this one's compounded monthly. Okay, so I know I'm going to be using y equals a 1 plus r over n raised to nt, because we have to compound it monthly, which is 12 times a year. So n equals 12. That's my a value. So 14 years, they gave us our time. They want us to figure out the interest rate, so we're going to solve for r. And we're going to solve for r if my final amount is 157,000. So I have 157,000 equals the initial 94,000, and then times 1 plus, we don't know the rate, so instead of saying r, when we plug it in Desmos, we are going to say x over 12, and then 12 times the rate. Or excuse me, my time, which is 14. okay? So I've got to be very careful when I plug this in and make sure I have everything the way I need it. So when I go put this in Desmos, we'll hit the home button so we have the full effect. So our original was 157,000. Then we have y equals 94,000. Let me make sure I got all my numbers right. 1 plus, I'm going to go ahead and do that division. We don't know the r, that's what we're solving for. So we're going to do x over 12 because it's compounded monthly. And we're going to raise that to 12 times 14. Again, you only see one graph. So I looked at my y value and I have 157,000. So I'm going to go hit that, go to my y-axis, and I can just do 160,000, like I said, to give myself a little wiggle room. And I can see it here. And then I can start to zoom in and kind of focus in on that area so I don't make a mistake. So I got 0.0367. So 0.0367 is the decimal I got. Now the question says to the nearest tenth of a percent. So we have, first of all, we got to turn it into a percentage. So to turn into a percentage, we multiply it by 100. So we get 3.67%, but they want us to the nearest tenth, so it's going to be 3.7%. So 3.7% is going to be my final answer. Again, they're going to show you how to work the whole problem out. As you can see, it's probably going to be much easier for you to just go ahead and put that straight into Desmos. Okay? If you have any more questions or if you want me to work any of these out the long way, I'm more than happy to. I just figured that this would be easier for me to kind of process these with Desmos. All right, so for this particular problem, it's asking you to compare two types of equations. So one of the suggestions I made when I'm looking at these is, for some reason, they're weirdly formatted in a mixed fraction. Mixed fractions are not going to work for us. So if I have 3/4 and I go ahead and take those 3/4 and I divide them, it's going to give me that decimal. So 0.75. So this is actually going to be 9.75%. So go ahead and convert that. And then we have 5/8. So if I do 5/8, that's going to give me 0.625. So this is 9.625%. So then they're going to ask you to compare it. So it says Aiden invested $43,000 and is paid at 9.75% compounded continuously. So for Aiden, I'm going to use my continuous formula. All right, and then for Levi, it says that he is being compounded monthly. So for monthly, we're going to use our compounded formula. All right, so then it says after 13 years, how much more money would Aiden pay to the nearest dollar? So first we got to figure out how much each one paid individually and then compare them. So for Aiden, he paid, we have 43,000. So y equals 43,000. E raised to my rate. So instead of 1.9%, we're going to divide it by 100. That's going to give me 0.0975 times 13 years. Okay? So I'm going to go plug that right into Desmos. Sorry about that. So we're going to plug that right into Desmos, and we are going to raise that to the 0.0975 times 13, and we get 152,000 734.3. Okay, so that was Aiden. So now we're going to compare this to Levi. So Levi, he was 43,000. He had an interest rate of 9.625. So when we divide that, so yes, it's going to be a long decimal, but you got to write the whole thing. Divided by 12. And then we're going to raise that to 12 times 13. So again, we're going to put this into Desmos. 1 plus, we're going to go ahead and do 0.09625 divided by 12. And we're going to raise that to 12 times 13. And we get 149,524.3. Now, it says to the nearest dollar, what's the difference? So I'm going to subtract these two. So I'm going to subtract them and find the difference here. So I'm going to go back to Desmos. 152,734.3 minus 149,524.3. And I get $3,210 difference. And that's what I would plug in. I would plug in that difference. I think I still have it open. So 3,210 is the difference.